Hello, welcome back. This is Engineers. This is actually one of our first lockdown sessions, and we've got some fun sessions to come over the days and weeks. We've got some guys in Barcelona, we've got some guys in Amsterdam, some guys in London that are taking the time to talk to us a little bit about what they're building. So we've got the lovely Adnan from Glovo. Adnan's going to tell us a little bit about the Glovo product, machine learning ops. He's going to talk to us a little bit about marketplace optimization. I'm going to let Adnan intro himself. I'm going to follow up with some questions after that. So listen up. If you've got any questions, feel free to reach out to Adnan post this. He's probably the best one to ask those to. Uh, Adnan, do you want to kick us off? Tell us a little bit about who you are and what you do.
Thank you, Elliot. So my name is Adnan. I'm currently the director of engineering here at Glovo. I'm leading the dispatching division or dispatching cluster. We call them here clusters at Glovo.
Hmm.
Um, I joined Glovo 5 years ago. I was part of the initial team that's started here. It's actually the first engineer after the CTO.
Nice.
I've been here for quite time, like quite long, and we're part of the first MVP at Global Developer was called Global 1.0.
Okay.
With next versions, and I developed a couple of things. Been here also during the time we kind of expanded to we went international as in like internationally expanded to more countries, we are here, and happy to kick off this, Elliot.
Let's do it. Offline, we've obviously talked a little bit about marketplace optimization and what that means to you. So, do you want to tell some of the viewers what marketplace optimization means to you and Glovo and some of the teams?
Yeah. So as you know, I mean, Glovo is an on-demand delivery company. So what we try to do here is make everything accessible in your city for you. So basically, try to move any product or anything from any local place in your city as a consumer with a top of button.
Yeah.
So it's a two-sided marketplace. We have like stores, which is restaurant, groceries, pharmacies. You have customers from other side, and you have the fleet and the couriers. So in this context, that the marketplace part, and obviously here you have supply, you have demand, and basically here optimizing like the optimizations of the like optimizing the marketplace becomes a key problem at scale. If we again simplify, it's basically what we try to do here is basically satisfy the demand that you have with the resources and the supply you have in a most efficient way. I'm gonna dip a bit into the details
Yeah.
later on, but that's in a nutshell. That's what marketplace optimization is.
Yeah. Okay. For anyone listening, so you can associate this with other brands, it's a little bit like Postmates over in the States, or it's a little bit like Deliveroo.
Yeah. So I would say it's like Deliveroo and Uber Eats, but we do more than food. So we basically deliver anything from pharmacies, groceries, even your keys. You can move them across the city. So
House keys.
house keys. And
Seriously.
it happened to me a few times. So I lost my keys and I had to bring them from the office, and I had to,
Amazing.
yeah,
I love it.
yeah. So I mean, it's up to the user at the end. I mean, you can be creative with the service and use it for different in different use cases. So
Awesome.
cool.
Awesome. Uh, Tell us a little bit about what sort of problems you're trying to solve at the moment. And I think what would also be interesting is maybe the trajectory of some of those problems as you've seen some of the scale increase.
Yeah. So maybe we start here a bit, like giving a bit of history where Glovo came from, and
Yeah.
and how problems shaped and evolved in the company across this year. So I mean, Glovo started. So the main focus was like finding the product market fit and grow the product. for like mainly growth. Like main focus was growth, so like quite customer acquisition, and kind of bring as many customers as you can, and as
Yeah.
well like expand geographically. So in the beginning, like there was less kind of focus on cost optimization and making things more efficient. The goal was like, okay, how we can expand and grow as fast as possible. So that's kind of shaped the way how the product and tech was evolving in the first, like, let's say 2 3 years, something like that. And
Okay.
so my focus from engineering and tech product, the whole company actually, is like how we can grow, more, for existing markets and also for new markets, acquiring more users and
Yeah.
building a feature. And actually, we did that's amazing. So I think given the prior we kind of came to. The growth we achieved, and it was kind of interesting, and we kind of today we have one, like we're customers kind of love Global because of the product we
Yeah.
built and this user experience we provided to them, to our product.
Yeah. Acquisition and retention is unbelievably key
Yeah.
right now.
Yeah, and that pushed us to do crazy things behind the scenes, like there's ideas that look magical, that they're behind the scenes, a lot of efforts, a lot of things that probably couldn't scale at that moment. But like the focus was like, okay, let's satisfy the customer, make
Yeah.
them happy, lead grow as much as we can, and obviously we're gonna get to the time to make it scale and make it more efficient. And that's when the kind of the focus of the company moved to that part.
Okay. Well, so you went really adventurous with some of the product features that you were trying to build. Is that what you're saying?
Yeah. So yeah, we pushed it to the limit. So yeah, we had like small team, but we were kind of like we built a lot. So like we started like in the beginning, we started with this little, like let's say simple app with two buttons, so you can basically do just two things: move things around the city, or just you know ask for something to come.
Yeah.
In Spanish it's called Quiero, but like order anything. But then we
Okay.
brought it to this sort of marketplace, which kind of like provided like a catalog of stores. We called it a wall, the wall version of Glovo. So you go and you find all the stores in your city, and you can like stores can integrate with your app. And it's evolved more with like providing more options and more features for customers, like tracking your Grover actually was one of the first features, but we did a lot of kind of improvement to that. So yeah, I
Yeah.
mean, what I was said, like in the first 2 3 years, the main focus was the customer, how we can
Yeah.
acquire more customers, retain them, and grow as fast as we can.
Yeah. Okay. So first couple of years, what followed on from those years? Like I said, with the trajectory and so many products, so many features, the scale was or is enormous. What sort of problems do you run into now?
Yeah. So obviously, I mean, that was a big success for Global to kind of grow that fast, and both in customer base and also geographically to one. Like we went to 23 countries, and yeah, we know that customers liked and loved our product.
Yeah.
With that, we have a product that customers love, and they are willing to kind of stay with it. But yeah, then problems start arising. I mean, there are problems that we kind of decided to kind of ignore them in the beginning and start facing. One of them is efficiency. So,
Okay.
if you can, efficiency is like how much you can, like how efficient you can utilize the fleets, your couriers in the city
Yeah.
to satisfy as much demand as you can have in, on a cost efficient way, as fast as possible, providing the best customer experience. So we don't focus a lot on that area. Like in the last year and a half, let's say, the company decided to invest on that and have a team dedicated to this, which is the dispatching team that I'm leading. And the main
Yeah.
focus of that team was like, yeah, we want to optimize, we want to increase the efficiency of the fleet. So like to simplify things, like efficiency is one is a KPI we have at Global, and it's basically the number of like it's described as the number of orders a courier can do per hour, and
Okay.
that determines like how many orders a courier can do, like how fast you can do them, how fast you can get to the customer, the cancellations, a lot of things that kind of relate to that let's say North Star KPI. And that's the
Yeah.
mission of that team, is like how we can bring that number up and like push it through technology and products and operations.
Okay. Do you, or are you allowed to tell us a little bit about some of those numbers and complexity that at, let's just say, peak times
Yeah.
in some of those cities you might see per hour, orders per hour?
um Yeah, so maybe well, yeah, it's not too much to reveal, like because a lot of problems happen at the local scale. So we're talking about, you can reach like, let's say, thousands of orders per hour in peak hours.
Yeah.
So during, for example, lunch and dinner time, like you have like thousand fleet, like thousand couriers, thousand orders,
Yeah.
and like combinations of how you can kind of assign them, and which who is doing what are
Yeah.
infinite. It's combinatorial, it goes like crazy, and every single decision makes a difference. So it
Okay.
becomes like, yeah, a key optimization problem to solve here.
So if we deep dive a little bit more into those optimization problems, how have you actually integrated some of those machine learning solutions that you've built into your products to actually understand, okay, where can we be more optimal?
Yeah. So maybe I can rephrase a bit that. So probably like here we can say is like how machine learning helped kind of push that problem to limits that wouldn't be possible without machine learning. And to
Okay.
touch on this, probably I would take a step back and explain like briefly how the how the optimization happened. So basically, as I mentioned, there are like thousands couriers in a city, thousand
Yeah.
orders. You try to find the best optimal solution. How we solve this problem? So actually, it starts a couple of days before. So there are like team called forecast. I try to kind of know in advance how many orders we're gonna have per hour, per day, and per city. Yeah.
Okay.
So given that number, we can actually know how many couriers we can have. So as you know, our
Yeah.
fleet is autonomous, so they're free to kind of like decide. You can decide to work or not. So
Yeah.
we provide them like a sort of a calendar, and we open slots for them. We call them slots, and you can go and say, okay, I want to work on this hour and that hour, and that slot fills based on the numbers that we forecasted. So that happens a couple of days before, and it keeps like continuously, obviously, adjusting as new data come to the platform. And when
Yeah.
the moment comes, a customer places an order. That's the like the fun part. So we basically need to find, for each order, who's the what's the fastest way we can deliver it,
Okay.
minimizing different time components. Actually, we don't solve it at the order level, so we solve it at the city level. So we look at the whole city and said, okay, what's the time? Like we try to optimize what's the customer delivery time, the courier delivery time, for example, cancellations at the city level for all the city, not like one by one. And
Yeah.
to do that, so this is basically an optimization problem here that you can formalize it mathematically using operation research techniques
Okay.
and stuff, and you can simplify it like by saying, okay, for each order in a courier, I will add like we will have a cost, and that cost you can define it based on your business, based on things that I mentioned, delivery time, for the courier, delivery time for the customer, because you will end up impacting his experience, chances of cancellation, chances of rejection, and this sort of things, and also time, how much time, like how much is going to take for the courier to wait at the restaurant.
Yeah.
And so you can notice here I'm talking a lot about time. So a lot of a lot of components, a lot of input that go to these cost functions are protection. So to be
Yeah.
able to know which delivery is faster, you need to kind of predict how much time does it take. So you can think of it as like you have a courier, you have two couriers, which one can arrive faster to the restaurant, who can pick the order, like how much time it would take him to wait there and pick the order, and how much time it would take him to deliver. So that's the simplest scenario, assuming that the rest, like the food or the goods, are already kind of prepared. But you can add
Yeah.
more complexity here, because like like saying that the food just came to the kitchen, and it's going to take more, like it's going to also take time to get ready, so things are not ready yet. And here you can think from use cases: you want a salad or a coke, versus like you want a pizza, or you're ordering, I don't know, a sushi that's not ready, and times vary from few minutes to 40 minutes. And
Yeah.
you need also to kind of predict the preparation time of that particular order for that restaurant, incorporate that into that cost function I mentioned in the beginning, and
Yeah.
try to minimize both the time it takes for the courier to arrive to the store, the time it takes for him to wait at the store, and the time it takes for him to travel to the customer, and probably the time it would take him to do the second order. So a lot of predictions here I mentioned, and yeah, that's what we use. Just like kind of there was machine learning kind of play a big role here, and we have models to predict all of those components.
Yeah. The problems that you have to anticipate are scary. Are there sub problems even underneath that, or are they really the basis of some of the problems that you're likely to encounter?
Yeah, I mean, like if you go to each problem, there are actually sub problems to it. So if you go to each, for example, let's say preparation time, you just like you need to classify the restaurants, for example. Are
Yeah.
they, the Italians, or like Mexican food, with the size of the order. So what we call features, machine learning, for the models, there's called features, so we can incorporate into models to make more accurate predictions. The most
Yeah.
interesting place here is that you try to predict something that you don't have the ground truth for. So
Yeah.
we never, like, it's really hard to know what's happening in the kitchen, and you really hard to know when the order is going to be ready. So it can happen that your motor is off, like it's overestimated. Let's say instead of saying 15 minutes, takes like 1 hour, and the courier just keeps arriving 1 hour late, and no one knows, because there's no, like, hard to get that feedback from the kitchen. So here you need to
Yeah.
work with product. You need to kind of try to capture that signal from, like, let's say from inside the store, in a
Yeah.
user friendly way, or like in a way that it's easy for the store, and also can be easily incorporated that's one problem. If you look at
Yeah.
the travel times, obviously makes difference if if traveling with what time of the day, traffic, you can see the speed. So it's we noticed that, for example, like in summer, in some cities, things like couriers will start moving faster, because the cities are kind of not crowded. People would go for vacations, or they didn't go out, like they don't go out during the day. So you have to
Yeah.
incorporate that signal as well, and weather. There are lots of things that we kind of incorporate in that.
I'm going to ask you two questions, kind of at the same time, just because I'm thinking, wow, there is a lot to consider. Right at the start of this, we spoke about ML ops or machine learning ops. So, how do you deploy some of those solutions that you've created? And you mentioned there working with product teams. Okay. So how are your teams set up? How do you work with product people that closely? Because there's a ridiculous amount of factors that you've got to take into consideration when you look at an order. So I'm really interested. Bring it back. How do you deploy some of those solutions that you've built, and how are your teams set up?
Cool. Yeah, so let's start with the team setup. So at Glovo, we have teams structured around product teams. So
Okay.
effectively, each team is kind of focused in one area of the product. In the context of marketplace optimization, is the dispatching team. It's structured around three teams, similar to what like exactly maps to what I mentioned in the beginning. There's the forecast team, matching team that try to match things, and the routing. And for each team, we try to put like bring all the people that can solve that problem. So you can think of like data scientists and machine learning experts, software engineers,
Yeah.
analysts, product managers, engineering managers, all that, like all what this team needs in terms of people, they will be there. So all the problem, like
Yeah.
all the people who can solve the problem, will be bring there, and they work closely with operations people as well. So because here you need to understand what happened in the ground, yeah. So the decision or the things that decisions that you take are influencing people. So always have to keep this short feedback loop with operations in this
Yeah.
particular case. Try to learn why certain things are working a way or another. Like communicating with operations manager, local operation managers in each city to understand the impact of your features. And yeah, I mean that setup helps has to keep like short feedback loops, so all the people kind of closely working together.
Yeah.
All the models are taken care of by our machine learning data scientists. So basically the people who are iterating on that model and trying to make them more accurate, even bringing new models to production to solve, like as I said, sub problems, problems and sub problems. In this case, so how machine learning works. So for all those problems that I mentioned in the beginning, like predicting preparation time,
Yeah.
predicting travel times, predicting like forecasting the demand and supply. So they solved at the city level. So each city kind of had like its own models trained in its own data. So
Yeah.
in context, so at Global, we have around, let's say, 300 cities. So for each use case, we have 300 models in productions, and those models
Okay.
are deployed or retrained every week. So every time we have a feature, it's added mostly to all the models. We track them, we track their errors, their like monitoring. We even deploy them, in a weekly basis. I mentioned, or even when we do new iterations on them, we kind of similar thing happens here. Obviously, I mean you cannot have people just behind laptops deploying these models.
Yeah.
Because manually, where here MLOps play a big role. So all of that we try to automate it. So we have like a third team here, which is outside of dispatching. It's called machine learning platform, and that team kind of supports that science is bringing them, like giving them tools to basically automate, the low level work for them. So if you talk about deploying models, so this team will kind of give them like pipeline, like tooling to basically do that
Okay.
automatically. Yeah, it's, let's say it's Monday, training will trigger, the model will be ready, a report will be sent. If there are like any errors, they will be kind of sent to the people concerned. Obviously, still today you still have a final check from the data scientist to kind of say, okay, it's okay to go to production. We're also planning to kind of
Yeah.
eliminate that improvements, like the only thing, because like those models are critical. So once a final someone to drop a look at that, then they will like confirm it, and the deployment will happen automatically. So we do a rollout of those models. Obviously, there's a lot of monitoring around it. So things like infrastructure or
Yeah.
low level like memory, CPU usage, latencies, throughput, and this sort of, and also business metrics and business alerts. Like in the context of preparation time, you would try to know, like try to kind of monitor what is the average preparation time of that given city. You expect it to be in some numbers. If it goes crazy, for example, if the pizza used to be 20 minutes and suddenly you did a change and it started taking, like predicting 2 hours, obviously an alert will go off automatically,
Yeah.
and someone has to jump into it and look at that. And obviously there are like mitigations that we can do there. So yeah, I mean during the whole process, since this is like a lot of models going to productions, a lot of iterations happening, we try to push for automation and as much as we can. And that what I mentioned about the machine learning platform team
Yeah.
that kind of provide the tooling for data scientists to kind of automate this part of the work.
Nice. Okay. Um, Tell me a little bit about, or tell the audience as well, a little bit about some tooling and technologies that you use in the dispatching team, and I guess how you best leverage some of those at times.
Yeah, so we actually, yeah, so I mean, the models that we kind of got, I mean, the typical data science toolkits, it's Python, so a lot of Python happening there. We actually leverage AWS and yeah, we use SageMaker internally to kind of expose the APIs for productions. In terms of libraries, depends on the cases. A lot of like things like XGBoost, like GPM, the different libraries are being used by data scientists, data science team, and everything like the model at the end is a binary, a Python like a binary file wrapped behind an API. We deploy it as a black box and try to kind of monitor the metrics over that. We have our observability system
Yep.
here. And yeah, so that's the typical thing. So each kind of use case is deployed in isolation. So preparation time are separated from the rest, of sort of like microservices architecture, let's say. And the other parts of the world, like consumers of those machine learning models. So you have the matching engine. We have a name for it. We call it Jarvis. It's coming from
Jarvis
Jarvis.
or Jar?
So it's coming from the Iron Man movie. So
Okay.
the suitcase. So the suit of Iron Man, that smart intelligent system that tells you what to do. So we gave it.
Love it.
We build it.
Can you take the glory for that name?
Yeah.
You can take the glory for it.
Now it was me and the other person. We developed the first version.
Nice.
So I mean, we dropped it, but then it became like a kind of a famous name.
Good.
Famous name there, and yeah. So yeah, that's the system that consumes that. In terms of scale, I mean, we're talking about like 1,000 orders, 1,000 couriers, and you need to look like like most of the cases you need to look at the different like possible combinations between those orders and couriers, and we're talking about million productions per minute for those machine learning models. So really high throughputs in there, like milliseconds of latency kind of play can change things dramatically. So I have like SLAs and SLOs around that. So we expect our models to be fast, like really low latency. In that, a lot of caching happening to avoid repetitive productions. And yeah, so that's the consumer part of this machine learning models as well. Like the matching engine itself is quite a complex problem. So there's a lot of mathematics and also operation research, as I mentioned. So as also an optimization problem. So you can try to solve it with using linear programming. And the interesting thing is you need to shard, you should need to kind of split your problems per city. So if that problem is being solved, let's say
the localization is just it's mad. There's so much.
And you need to kind of make it fault tolerant, highly available, and at the same time you don't want to two agents, let's say two processes trying to find a solution, like making the decisions about your city at the same time, because one solution can give you give you one output.
My light.
Yeah. So
my light's gone funny. It's all right. We'll leave it. There we are.
It's okay. I think you're gonna cut this from the
No. I'll leave it.
Yeah, great. It's So as I said, so if you have two solutions coming at the same time, that will probably give you the wrong result. So as I said, like you ensure at any given moment in time, like one worker or one agent is making the decision about your city, and if that worker or that process failed, someone can recover. So distributed locking here, making this scale per seat, across the globe come interesting. Behind the scenes, I mean, there's nothing really complex, so really kind of built it on top of MySQL, with Java, playing around with thread pools, and develop a sort of an in-house custom distributed lock that we kind of it's working now. Obviously, a lot of iterations to do on top of it. to make it scale, and probably like always kind of the focus of the team. But yeah, I mean, I wouldn't say there's too much complexity, or like we try, like we didn't bring a lot of complex or fancy solutions. We believe on keeping things simple,
Yeah.
and fall back to our traditional tooling.
It it seems that way. It's really refreshing actually to listen to you, and you use the word iterate a lot, and you're always thinking back to your roots and why you've built this. So, are you able to give us any indication as to maybe how you look at your data and continue to be more optimal with what you're doing? Is it data driven? Is it emotionally driven? How do you look at things and think we need to make that better?
Yeah. So in general, at Global, I believe that we have a strong data-driven culture. So most of the decisions are being taken within a technology or business,
Yeah,
mainly driven by data, and that's actually cascade to, like to all the team. So what we do. I mean, obviously, in the marketplace optimization and problem solving, it's a lot of mathematics and things, but you still need to apply them on real world, right? So, and you don't,
yeah,
when you apply machine learning on those problems, algorithms, you don't know what's the reaction of the people, like with this, the reaction of couriers and customers, and yeah, you never know that, and that's play a big part of the problem here. So what we do is, like, within the team itself, whenever there's an idea coming, so, and actually ideas can come from everywhere, from operation team, business,
yeah,
even from within the team, from a learning that team got from previous features. We really challenge ourselves what we can do less to prove that this is working or not. So
okay,
what's the MVP version could look like? What's the how we can minimize waste, and like spend less time, implement that feature and prove it's working, and then, okay, either it's the it's the correct like it's the right way of doing it, and we can iterate and improve it, or maybe we have a learning and we can pivot and move to something else. So this is also, like, actually within the team we always have this. Whenever something new comes, and especially in the product discovery and the exploration phase, what we can do to prove, what's the minimum thing we can do to basically prove that this is working. And it comes, for example, to machine learning problems, like, okay, what's the simplest
yeah,
dynamic model we can put in production, have a baseline, we can understand what's happening, and then probably we can iterate. Want to put a feature in the, a new feature for the engine to start, let's say, kind of like, let's say, we want, for example, to make a difference between both, like, perishable food and non-perishable food.
yeah,
Instead of developing some let's say, a fancy algorithm that kind of captured that, let's do it manually first. Flag it and see, if that's going to add, make a difference or not. And you get tons of learnings there with minimum
yeah.
investments. And yeah, I think it's part of the DNA of Global. So always been the,
Okay.
the, the case, and it's played big role of the way how we do things here.
It's a great
With
culture
matching, yeah.
to have. It's such a good culture to have. One of the last questions that I want to ask you is, genuinely, it's been fascinating listening to you, understanding more. What do you wish that you know now that people listening to this can get a lot of value from you from, whether it's failures that you've had an opportunity to learn from, implementing things and seeing things go wrong, but what value can people take away from this, or maybe what principles or ethoses that you guys continually run on when building in your teams?
Yeah. Well, I think one of the biggest learning we have within this part, like the parts of the problem, especially optimization of marketplace, it's yeah, it's full of, like, algorithms, machine learning problems and things, and now gets people excited about it.
Yeah.
Yeah, you go there, you do an optimization. It's mathematical. 1 + 1 = 2. And the biggest learning, at Glow is like in the beginning is like when you go to real life and you put it in the ground, it's you're like things go differently. People may react the way they expect them to react to things, even if you do show them the right information or the accurate information. For like as an example, like I can give you a simple example. Like we try some moment to have as a simple feature for our kitchens or our restaurant to basically kind of declare when the food is ready. Team was excited that capturing the signal, we will know exactly when the restaurant will basically have the order ready, so the courier can comes and picks it. And yeah, we did that. Started kind of rolling it out. What we realized later is that people are not using that button.
Yeah.
Yeah, so we realized one of the learnings was at that moment, it's like kitchen will be busy. There are like tons of orders coming to you. The last thing, and maybe you also have locally in the restaurant, you have other people sitting around, and the kitchen is super busy, highly saturated. The last thing you would think is go to a tablet and pick that button. And yeah, I mean, it was kind of frustrating because like the team invested some time putting that feature, but it proved that it's not always a big learning because before it's always can do fancy cool stuff, but
Yeah.
the way how people or humans react to it make a huge difference.
Yeah.
And you always try, you need to make, you need to find ways how you can include that parts in your experimentation as well.
You really need to stress test things like that. You almost need to be in the restaurant cooking the food and going through that process. It'd be interesting to know if anyone actually has at Glovo, to be fair. But you almost need to be in the restaurant
Yeah,
uh, doing that job and going through that process to understand how someone
yeah,
thinks.
and that's actually how we started encouraging yeah, we start kind of like you know working with the teams to make them go through experiences like that. So, for example,
Yeah.
within the team, we try to do like workshops with their operations team, customer support, even go and do local visit to restaurants and see how they do things, how they react to stuff. It was a big
Yeah.
learning. And we started doing it. We started learning a lot. Like when people think differently about certain problems, and we realize that certain features might not make sense, or certain problems probably they are not fit for that,
Yeah.
for those use cases. So yeah, it shaped as well like the way how we do kind of product discovery, how we involve engineers,
Yeah.
data scientists, analysts in those problems, and how we work together with people in the ground to properly solve the
Yeah.
problems.
And talking to people over the years, I think in their product discovery piece, what they think they're building that is relevant for people is, it's on a spectrum. Like either it's just marginally off or so off. What actually happens when someone's using their product.
Yeah,
Um,
definitely, I agree.
last last question. Well, it's not necessarily a question, but um, this is for you guys, the amazing team at Glovo, to be able to, I guess, showcase a little bit about some of the roles that you're hiring for. So, anyone listening that is in Barcelona or thinking about moving to Barcelona, do you want to just give us a quick insight into what you're hiring and why maybe someone should come and join? Obviously, all the fantastic things that they've heard
Yeah,
over the last half hour, but what are you hiring for?
yeah, we're looking. I mean, across global, we're still growing the team. We're still like looking to grow the team and go. We like grow it significantly over the next few months. We're around, let's say, I think around probably 200 engineers. I want to get uh, we're gonna get more folks. So bench of roles open. So looking for engineering managers across different teams, from customer experience, partners, couriers, even dispatching here, and like for people with experience in like working with large scale systems, working in tech companies, startups, entrepreneurship mindsets, willing to kind of, be, be parts of like a full kind of autonomous product team, working with different people, not only engineers, and help us as well grow the team. So as I said, like we're growing significantly the team. So a lot of things changing, a lot of things
Yeah.
happening at the same time with our processes, with our like methodologies. So you get a chance as well to influence just sort of things. If you're, whether you're an engineer or an engineering manager. So yeah, we're looking for a bunch of roles, as I said, like engineering managers, data scientists, machine learning people, software engineers. So yeah, drop a look at Global Jobs website. Sure, you're gonna find a role that fits you. And yeah,
Good.
happy to talk to you.
Um, this has been really, really insightful. I've thoroughly enjoyed it. Everyone that's listening, you obviously had some fantastic insights from the guys at Glovo and Barcelona. If you're looking for a job, go and talk to these guys. Go and talk to Adnan on LinkedIn. Connect with him, and I'm sure he'll direct you to the right place as well, or maybe talk to their talent and HR team. From us at Engineers, give us a like, give us a share. If you're really interested in talking to us about your journey, we'll make the time. We want to represent brands, and we want to talk about some of the really, really cool things that you guys are doing. And come with us and talk to us about something that you want to share that people can learn from. That's the most important thing. We're creating a sharing platform. So please do that, and you're going to see some more lockdown sessions from us. So it's bye for now. Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Engineers is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Engineers.io. It's no_. We've also got a website which is engineers.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.